All right. An architect wants to determine the relationship between the height in feet of a building and the number of stories in the building. I'm going to underline the word relationship. A sample of 10 buildings in Pittsburgh give the following data. So we've got stories and height. Here is one pair of data. That would be the first x, x1, and the first y, y1. So we've got 10 data pairs, 10 values, and we need to enter in these values into our calculator. First it says graph the data as a scatter plot, then we'll find the correlation coefficient on our calculator, and we'll describe the relationship, either a positive linear relationship, a negative linear relationship, or something like no relationship, where we get something kind of near zero. First, let's go ahead and graph it. So I'll go ahead and do an x-axis here, and I'll do a y-axis. And the x-axis is number of stories a building has, and the y-axis is the height of the building in feet. So if we look at the two variables, we can find out kind of a good range that will capture them. The stories, so I'm looking at this first row. Let's see, the lowest value I think is 31, and the highest value seems to be 64. So I'm going to skip the first 30 values. I'm going to do that little squiggly line that says I'm skipping some values, and I'm going to start at 30, 40, 50, 60, 70. So 30, 40, 50, 60, 70. I could do a little bit better of a scale. They're not quite the same width, but you get the idea here. A pretty consistent scale that will capture all of the values that I see in the X category and the number of stories that a building has. In the height category for Y, now I'm looking down here, the lowest value seems to be 485, and the highest value is 841. So we need a scale that will capture those values. Again, I'm going to do a little bit of a jump on that axis, do a little squiggly line that says I'm skipping some values, and I'm going to start maybe at 400 and go to 900. So 400, 500, 600, 700, 800, 900. And then we could do extra tick marks that will be the 50 points. So we're just kind of estimating. So we're going to graph each point. Each data pair is seen as an XY point. So for this first one is 64 stories and 841 feet. So the X value is 64. So that's about here-ish. And then I go up 841. So 64 to 841 is, estimating somewhere kind of around here. For the next point, it's 54 stories and 725 feet. So let's plot that one. I'm going to do all the points in pink just so that we can kind of see the relationship if there is one. 54 is about here, and then I'm going to go up to 725, about here-ish. Doesn't have to be perfect, just an estimate. Then we've got our third point, 40 to 635. That's about here-ish, maybe a little bit lower. 31 to 616. That's about there. 45 up to 615, about here. Oh, I'm going to go a little bit lower, actually, on that one. 45 to 6, about there. 38 to 582. 582 is about there, right there. 42 to 535. About there, maybe. 41 to 520. That's pretty close. 37 to 511. That about there. And 40 to 485. About right there. They are kind of clumped together in that region. So this is the scatter plot. Just a scattered collection of points, each pair of data. We should have 10 points for the 10 buildings. I had to verify really quick. There are 10 points, each one representing one of the buildings that was sampled. Okay? So it kind of seems like there is a positive linear relationship, meaning it kind of seems like we have a line that could go up this way that kind of predicts our data. It is kind of predictable. The data is kind of following a trend, a bit of a line. So my guess would be a positive linear relationship. Relationship. I'm going to put question marks. I don't know if this is true. We're going to have to verify this with the correlation coefficient R. Remember, R can be between -1 and +1. -1 means a strong negative linear relationship. +1 means a strong positive linear relationship. And if you get a value close to 0, it means that there doesn't seem to be a relationship. If you get a value outside of these ranges, say 3,472, you have definitely made a mistake and you need to check your work. So now I want to enter these values into my calculator and have it find me the correlation coefficient, which we tend to round to 3 decimal places. So I'm going to turn it on. I see I'm already in stat mode, so I'm going to go, and now I see that right here. I'm going to go ahead and exit stat. Now exit stat is up here, so I'm going to hit second, exit stat, and exit stat. Yes, I would like to exit stat. And this will kind of clear the data that I had in there. So now I need to go back in there and put in my data. So I'm going to go into my stat menu, which is right up here, second stat, and go to 2 variable statistics. We are dealing with 2 variables here, stories being one, height being the other. And we're comparing them. So once I select that, the screen goes away. Now I want to select data and input my data values. As soon as I hit that, it says, okay, what is your x1? What is your very first x value? That is this one right there. That is our x1. And this is the y1 that goes with it. All right, that's the first pair of points, x1, y1. So I'm going to hit 64, and the corresponding, I hit down up here, and then the corresponding y value is 841. Now I'm going to go on to x2, y2. So I'm going to hit down again. There's x2, which is 54. y2 is 725. So for x2, I'm going to hit 54, go down, y2, 725. And I'm going to start speeding through this. Our third point has 40 for x and 635 for y. Our fourth point has 31 for x, 616 for y. Our fifth point has 45 for x, 615. I don't know if I repeated that. We'll find out. For y. Our sixth point has 38 for x and 582 for y. Our seventh point has 42 for x, 535. You get the point. Wow, that's the longest I think I've ever been quiet. Let's go ahead and now run our data. I know I'm done because I've come to the end of my list there, which I believe should be x10, y10, my 10th data set, okay, my 10th data point. Now that I've done that, I'm not going to go and enter anything else. I'm going to go straight into stat var, which is going to allow me to run some calculations. It says, ooh, I'm going to calculate. The first thing that comes up is little n, your sample size, which we guessed was 10. We should have, it's another way to kind of check our work. And we're going to scroll our way down. We don't care about the sample mean or the sample standard deviation or the population standard deviation or the, I don't know what this is. This is the sample mean for the y values, sample standard deviation for the y values, the population standard deviation for the y values. We don't care about all these sums. We're going to go all the way to the end. We're going to say, I want R, which is, it goes A, B, and R. A and B have to do with linear regression. And R is that correlation coefficient. So R comes out to be 0.7973026. And like I said, we tend to round this to 3 decimal places. So I will look at the third decimal place and then say, all right, the number past it, is it a 5 or larger? And it is not. So we're just going to go bloop. Otherwise, if it was a 5 or larger, that 7 would get kicked up to an 8. So our correlation coefficient is 0.797. This is a little bit of a gray area, and I know that's because of this clump of dots right there, which is kind of not following any particular trend. It's a little bit of clumped up there. But if we think about where our R values can be in between -1 and +1, it's up here. And so it is leaning towards a positive linear relationship, which is kind of what we guessed. People often ask me what the cutoff line is, and I don't know if there is one for certain, but I shouldn't give you one that's in the gray area like 0.5 or 0.6. This is almost 0.8, which is pretty close to, a strong linear relationship. If you get something close to 0.1 or 0.2, -0.2, that's pretty close to 0 and would indicate no relationship. Awesome. I hope this helped.